Today we're going to talk about mechanical drawing. So that is what we do when we want a machinist to be able to reproduce one of our parts exactly. So if I gave one of you this part and I said, I want an exact copy of this, I didn't say anything else, do you think you could do it? Maybe? Okay, alright. What if I just showed you, if I did this, put it on the table here, took a picture of it with my phone, sent it to you, and said, I want an exact copy of this. Maybe it would be a little harder, right?
Yeah.
Because you don't know what size all these holes are, you don't know where they are, you don't know what angle this is at. You can't tell that just by looking at a picture or a render of it. So what we do is we make these technical drawings, which are two-dimensional representations that will show exactly where these holes have to be, how we round the edge here, and so on. So I'm going to show you the basics of how you make and dimension those drawings, and then I will bring up a schematic in AutoCAD of a part kind of like this, and have you guys try to walk me through doing it, and see if we can get all the right dimensions. So the goal is, when I put up a picture of this part, so I'm going to real quick draw a sketch of it, and then show you how you would dimension it. So basically, yeah. The goal is we want to have all the information we need to make the part, none of the information that is extraneous that we don't need to make it, and have it be human readable so that a machinist can look at it, can only interpret it one way. So if they follow the dimensions, they can only make the part correctly. There's no multiple ways of interpreting everything. We agree that's basically what the part looks like, minus the fact that I can't draw at all. So we've got all the wavy lines on there that are supposed to be straight. But we've got the little chamfer here, the slant here. It's hard to see maybe up here, but this tip here is rounded, so I drew it rounded there. And there are two holes. So what I need to know in order to make this part is, number one, I need to know what material it's made out of course, but I also need to know where each of these are and what size it is. So I need to know what features I'm going to put where on my part. And I don't want any extra information because that can get really confusing. So there are two ways I can do this in general. One is what we call chain dimensioning, where like I pick a starting point and I say, okay, this is 1 inch away from my starting point, and then I can say, okay, whatever it is, this is 6 inches away from the end of that. That's what we call a chain dimension, where we put everything, actually what I should have done is gone from here, then said this, let me do that. So I put these dimensions next to each other in a chain so that you kind of read from left to right or from bottom, top to bottom or whatever, and you see where every feature is relative to the last one. So in this case what I do is, okay, I put my center line here in my circle, and I say, okay. Now I say, okay, this one is like 3 inches away, and then I say, okay, from here then, this one is a further 1 inch, and so on and so forth until I'm done dimensioning my part. That's called chain dimensioning because the dimensions are like links in a chain. This is nice and human readable in a lot of cases, but if you're a machinist, especially if you're using a milling machine, a CNC, and you want to know exactly where every part is, another way to do it is what we call datum dimensioning, where I set every feature and I show where it is relative to this point, not relative to the last feature that I dimensioned. So instead what I would do now is I'd have a similar kind of setup. This one would be the same, but then I would say, okay, that's 1 inch away from this. The numbers don't matter. This part is going to be changing sizes. I'm dimensioning, it doesn't matter. So I would say, okay, that's 1 inch away. This is whatever, 4 inches away from this datum, this point. So this is like an exact point in space that we're starting from, and I'm saying, how far away is this from there horizontally? How far away is this from there horizontally? Over like that. So I get these dimensions like stacked on top like this. So this might be 5 inches away from my datum point. Did we get the difference between those two? How one is a chain of dimensions showing this is this far from this, so that's kind of like me saying, I take 2 steps over here and I'm at the chair, then I take another 3 steps and I'm at this computer here, and then so on. Whereas datum dimensioning would be saying, okay, from the edge of the board here, I have to walk 2 steps to get to that, or 5 steps to get to that, or 10 steps to get to the end of that. That's the difference. Yes?
So in datum dimensioning, in order to like figure out how far away the hole is from like the bottom edge, would you give
From
that?
From the bottom?
Or would that be considered chaining, and then rather you just give the distance from that point, your original point, to
I'm
the
sorry,
zero?
I'm interacting up. So datum dimensioning, do you
So,
figure out how far left?
So if you're gonna give a dimension, right? So
Right.
from how where that top hole is, would you give it from the bottom edge, or would you give it from your original point?
From the bottom, oh, I see, yeah, I'll show you. So, yeah, you're starting from this original point in both directions. So I could do it like this then. I could say, now I know where this hole is horizontally, but like you said, I don't know where it is in our y-axis here. That's what your question is? Yeah. So I would say, okay, this is 1 inch this way, then I can start on the other axis. I haven't gotten to that one yet. I can say, okay. Now I can say this is 1/2 inch up, and then I could start with I guess I would start with this hole first, because I'm going in order. I would go, okay. This is 3 inches up, or whatever it is. Yeah, so you're basically showing x and y coordinates to an origin. That's all datum dimensioning really is. Chain dimensioning being, like I said, sort of a relative thing, where this is this far away from this, and then this is this far away from that, and then this is this far away from that. Okay. That's how we specify position, but now I know there are holes here. I don't know what size they are, I don't know if they go through the part, I don't know if they've got like countersinking on them, I don't know if they've got screw taps. I'm not going to talk about a lot of that, because for most of you, the only relevant thing is going to be where is a hole and how big is it. So I'm just going to specify that. So now we know where our holes are. We want to know what size they are. We want to know like what size this is. Well, let me just finish up the where real quick on both of these things. Okay, so this is. If you haven't noticed by now, when you draw dimensions to a circle, you draw the dimensions not to the edge of the circle, but to the center of it, which makes it a lot easier for your machinist, because they're moving like a drill bit, for example. They're going to put the drill bit right over where the hole's going to go, then drill down and through. If instead I had dimensions to the edge here, then what your machinist will have to do is, if I tell you the diameter of this hole, he says, okay, this hole is 1 inch in diameter, so it's a 1/2 inch radius, so I'm actually going to have to go out this distance plus half the diameter. It's a lot more confusing for him. So with circles, we always specify to the center. Good, okay. Same thing over here, although this isn't a circle, so it's an arc of a circle, which changes something that I'll explain in 1 second. So now we know where all these things are. So I know where everything is, but I don't know what size everything is. I haven't done that. That doesn't matter. I want to know how big this circle is, how big this radius is, and so on. So for the circle, what I do is I draw a little diameter in here, put on a leader line from it, and I say, okay, this circle has diameter of 1 inch. Also, when you're doing a lot of dimensions like this, it's common to say, instead of having the inch symbol on everything, I could go like all dimensions in inches or millimeters or whatever I'm doing, and then I would just not have that symbol there, just to keep things simple. Anyway, so I specify where this hole is now, and I specify what diameter it is. So if I were a machinist, or if you give this to a machinist, he or she can go, okay, I go 4 inches this way, I go, or 5 inches this way, 3 inches up, and then I put in a 1 inch diameter hole there. They know exactly where it is, they can repeat that 1,000 times if you want. Any questions on that? Okay. if I'm specifying something rounded like this, it's not a complete circle, so giving a diameter for this wouldn't make any sense because there's no diameter, it never ends. So instead what we do is we specify a radius, because it is, in our case, this is a part of a circle. It gets weird when you're dimensioning parabolas and other weird curved shapes, but we won't talk about that. So here, instead of giving a diameter, I would give a radius. So I would go radius 0.5 inches in this example. And we know exactly where the center is here, and I haven't specified how high up this is, because if I don't specify that, we can assume that the circle, our little arc, is tangent to this line. So what that means is, like, I'm going to erase this now. We've got this line coming in, and I want to make a rounded edge on it. You can kind of imagine if I drew a circle, and I didn't specify what it was, that was not as terrible as I was worried it was going to be. So I draw a circle, and if it's exactly tangent, and I know exactly where the center is, and I know the radius of the circle, I don't need to specify anything else. We get that? Okay, awesome. So now we know the basics of how to dimension where things are, what size they are. I am going to bring up a free version of AutoCAD on the projector, and you are going to walk me through dimensioning a part, and we'll see how that goes. We don't want to put in any excess information. Like I said, I wouldn't also need to specify this if I already had the radius of this, because that's just extra information. That will confuse your machinist, because they'll wonder, why did they specify this? Is this not tangent? Is there some gap there? I don't know. Awesome. I'll bring this up. Yeah, we can get the lights down. Thank you very much. So I've got a somewhat similar part to the one I was showing and dimensioning. It's not exactly the same, and I'm going to point to like a circle on it, and I'm going to say, okay, how do I dimension the circle? What do I need to put in there? Soon. Any questions while we're waiting for this to come up?
You need to direct it to the correct source.
They can be unrelated questions. What is the meaning of life? Why is engineering so awesome? What's the deal with airline food? Is this just not explaining it? Yeah. Okay, yeah. Okay. That would explain a lot.
It happens to everyone.
Thank you, Kevin. Okay, so here we have a part that's very much like what we just had. And we'll put a few dimensions on here, just to make sure you guys get it. We have a rounded edge here, chamfered edge here, kind of like the old one, a few circles, so we're just going to dimension a few of these. In AutoCAD, I can just go dimension, okay, linear, and I could say, okay, from here to the center of this circle, like how long? So I can do that real quick. So, but the focus on this is what information do I need to give a machinist to do this. Let's start with this circle. What do I need to do?
Find the center of the circle.
Radius and the location of the view? Okay. So I should I do, let's see. So I need to know exactly where it is, so I can do, if I move out to the circle here. I can do that, right? No?
No.
Okay, why?
Because like the person wouldn't know like the angle at which
Right.
that line is.
Could, it would be weird and non-standard, but you're right, I could do this. I could give a length, and I could give an angle from this. That's not how we normally do it. There are cases when you want to, when it makes it clearer, but in general, I should do, what should I do instead? Yes?
You'd want to go like to the right and give it dimension
Right.
and then
So instead of that, I'll do dimension linear. I'm starting from my datum point here, up here, and I'll give X, and then I'll do it again. Start from here, and I will give y. Great, okay. So now I know where the circle is. You, Daniel, you also said I need the radius or diameter, did you say?
I just said the center of the circle.
Diameter, yeah, because it's a complete circle, right? So with dimension diameter now. Click on that. And there we go. Now I know everything I need to know about this circle. Yes?
The way you drew that in, how could you know that that's the center of the circle?
Wait, sorry?
The way you drew it in, how could you know that's the center of the circle? You kind of just guessed and clicked.
I kind of just guessed, oh, I'm sorry, I should have mentioned that. So, most CAD programs, this is actually DraftSite, which is a free version of AutoCAD, but just about anything where you can do this sort of thing will have a feature where it will snap, good, awesome question, where it will snap you to like important points. So if I go, okay, I want to dimension, let's dimension this next circle here. I start dimension linear. It's hard to see when I move close to this, that little box appears around it, and it lets me snap directly to that. So the program is recognizing like corners and centers of circles and stuff as important points, and will snap my mouse directly to them. So that way, endpoint. Now when I move up here, you'll see the center mark should appear, but it's not. Okay, there we go. See how that center mark appears? When I move close to it, it snaps right onto it. So I know that the computer recognizes, oh, I'm trying to dimension this to the circle, because the computer understands the standards here. Awesome, good question. Did that answer it? Okay, good, great. So I could repeat this process, I won't, but I can repeat this process for the other two circles, and you understand how that would work, right? How that would show me exactly where these would be. And if I did the same thing for this radius, now I would know the length of this, do this chamfer, and so on. And you can see how this, the convention is to stack dimensions like this to make them easily readable. Or if you're doing chain dimensions, for them to all be in the same line like this. Good, yes?
How would you tell them if like the side's curved?
The size of this?
Yeah.
Okay, this is, again, this is a an arc of a circle, so it makes it very easily. It gets very confusing when you have like parabolas and such, like, let's see, try something. I brought up like a project that has a whole bunch of drawings to see if I could find something weird to look at. But like when you start to get weird features like this, where you have like screw holes, screw threads and stuff, you can get a lot of weird looking dimensions. So we're just focusing on the basics. So in this case, we have part of a circle right there. So I will just go again, dimension, radius here. And as long as I specify how far this is away from here, we're assuming that this circle is tangent. We get what I mean by that, right? The circle just barely touches that line, and we cut the line off at that point. So if I specify how far out this is, I know where this point is on the circle, I know where the center is, I know its radius, I know everything I need to know about it. That answers your question?
Yeah.
Good, okay, great. The only other thing I'll say then is for this kind of chamfer here, you can dimension it two different ways. One is to dimension just how far this distance is, how far this distance is. Another way that can sometimes look cleaner is for me to dimension an angle. So I could dimension this angle here and then give 1/9, and that might look a little neater sometimes. That's really everything that you'll need to know, is where to put, how to put holes in, slots, linear dimensions, angles. If you're drawing them by hand, if you're doing it by computer, you won't have to worry about this. But if you're ever drawing by hand, try to make all of your numbers, like, you can be tempted to turn them like this and have them line up with the way the dimension is going. But it's a lot more readable if all of your numbers are facing or oriented the same way like this. Any other questions about technical drawing in 2 dimensions? Oh, yes.
A question about it in 3 dimensions.
In 3 dimensions, yeah.
So, like,
So this is a 2-dimensional part, right? We have no idea how thick it is. If I want to dimension a 2-dimensional part like this, if I know how thick it is, one way to do it is if it's just a plate with a bunch of holes and such in it like this, I could just put a mark up here that's like, hey, this is a 1/2 inch thick, and that's okay. Or I could start to add extra views to my drawing, which would be like this. Zoom in on that. So even though we don't have a 3-dimensional view of this part, by looking at all these 2-dimensional views, as if we put a box around the part and are looking through different sides at it, we can start to get a sense of how to machine this. We look at the front of it, we know where the circle is and how wide it is. We look at the side of it, we notice it's got this slope here. So you project different views of your part and dimension them all. This is not relevant for most of you, and Kristen was going to do a lecture on 3-dimensional CAD and like modeling for the 3D printer eventually, so since I've already been up talking here for a while, I probably won't talk about this in too much detail, except to say that you can do it. Project different views, dimension them all, but don't put any excess information in here, so if I dimension this and say this is this tall, I don't need to do it on this view too. The machinist needs exactly enough information to make your part and no more, because then they'll start to wonder, why did they specify here? Are those 2 different views? Am I not looking at the same thing? It get confusing and frightening, and machinists are very skittish and we don't want to scare them away. Any other questions? I think I covered everything then. So thank you for listening. That should explain to you how to make 2-dimensional drawings and dimension them properly so that you can have somebody laser cut or mill or even just bandsaw your parts and make them the same way every time in the way that you actually want them made. Dismissed.
It's